launch of geostationary satellites, and recovery of our space vehicles up to re-enter back into the Earth's atmosphere, injection of more than 10 satellites from a single launcher of PSLV were demonstrated. That we have the launches of PSLV as well as PSLV, and step towards our Indian space moon mission. Then came the big hit, Know Thy Neighbor, that is our Mars mission, which has gone ahead. This is a month of expected to be in the stage 3 of the performance. Then we have the aircraft program, which is within the DRDO, the Light Compact Aircraft, where the LCA Tejas, which has totally all-composite structure with a mass of almost 8.5 tonnage and a speed of 1.8 Mach with all minor abilities. And it has already shown its flight trials and its advanced stage of induction. The unmanned aerial vehicles, another category where in which a lot of research and work is going on. It's a UAV Nishan, which is used for the intelligence gathering, recce, surveillance, and the target designation, and very different purpose of application, high quality image devices for the surveillance. And the propulsion is basically the turbo propulsion, and it is recovered to a parachute. Then we have a category which is of the light transport aircraft, which is the SARAS class, and first Indian transport aircraft with multi-purpose aircraft functionality. We have now today world across and Indian, few of the things what is shown are all with the mini and micro air vehicles, unmanned aerial vehicles with this purpose. I think none of the videos are playing. So these are some of our unmanned aerial vehicles developed by DRDO. One now. And then coming to the Indian missile program. So this is to do with DRDO, where I am working. The video is shown of the Ram missile, anti-tank missile, where it is like fire and forget. It has a range of 7 kilometers to 10 kilometers, both working on IR and dual mode seekers. You will be seeing that it is a target. Yeah. So it is totally fire and forget, and it's going and it is demonstrated at 7 kilometers away. The tank is being destroyed. We have other class of systems, surface to air missiles, the Akash class of systems, 2 reaction interceptors, where a range varying from 300 meters to 70 kilometers has been demonstrated, with all network-centric operation, totally automated, and we have this has gone into detection and in big numbers. Then we have the air-to-air missiles, the Astra class of missiles, which is beyond visual range, that is a range capability more than 100 kilometers. It's again seeker, homing seeker and terminal guidance. Then we have the cruise missiles category, which is we had a joint venture with the Russian collaboration with subsonic, supersonic and hypersonic cruise missiles with 3 different applications from a land, ship and an air-based launch, range from 300 kilometers to 1000 kilometers, and we are enhancing up to 2000 kilometers. It's again grounded propulsion and terminal guidance. Then we have the anti-ballistic missile defense, like we all seen television serials, Mahabharata and Ramayana, where 2 arrows come and perfectly giving the pollution. But here again we have proven, DRDO has proven, both endo and exothermal atmospheric interception, that is missiles hitting each other at 18 kilometers as well as 45 kilometers interception with high accuracy, that is high altitude and both boost-based interception, with all the C4I and terminal Then we have the strategic system where which I belong to, that is a range of Agni series from 300 kilometers to 5,000 kilometers. We have the capability road, rail and underwater systems, canister launch capability. This year we are going for proving the canister launch version of Agni 5 and guidance accuracy, pinpoint accuracy. This is a series of 50 missiles where ranging starting from 40 kilometers to 225 kilometers, then improved version up to 350 kilometers has been proven with inertial guidance. The video is of Prithvi class, that is Danish missile launched from a ship, and this has a range from 80 kilometers to 300 kilometers. Again, another ship is launched, and this inertial guidance. Many people are in the ship when it is being launched. So that is the type of confidence and the accuracy which we build into the system. So then we have the Agni missile, where we were given the requirement of Agni 2 as the first missile, because as a government policy, India is committed to no first use of nuclear weapons. And Agni systems all are nuclear, and we need to prepare for quick response, low visibility, long storage life, and second strike capability. There is no first use. Somebody attacks, we have to retaliate. So the systems have to be so accurate and so quick in response. First, we were asked to make Agni 2 as our requirement due to friendly neighbors, 800 to 2,000 kilometer range, that is two-stage solid propulsion with manual re-entry capability. When I say manual re-entry capability, because these missiles once take off, it is like fire and forget, and once it takes off from the launch point, nobody can know where it is going unless only the missile knows where it is going. So even if anybody tracks by any of their means of satellite or whatever, in mid-course we can maneuver. The guidance built into us so so efficient that it cannot be tracked till the last minute, and the velocity at which it is traveling, it is impossible. As of today, it is impossible to strike by another missile. Then we have the A1 category, that is 300 kilometers to 700 kilometers, single stage solid propulsion, where the guidance is done first time in the country and world across. Also first time guidance scheme for a solid stage system was developed, and road mobile version has been proven. And then came the Agni 3, it's a 2-meter dia. The capability ranges from 1,500 kilometers to 3,000 kilometers, two-stage solid propulsion, all azimuth coverage. All the missiles have all azimuth coverage. When we say all azimuth coverage, from a launch point, anywhere between 0 to 360 degrees, any target within this range can be launched by this single missile. And it's a rail mobile version. Then came this Agni 1, 2, 3 are technology-wise singular class of technology, where we have used for the rocket motor structure as metallic, either a 16386 or a metallic steel, where we had benefit from switching over from steel to metallic steel, reduction in weight by say 50%. Then came the requirement. When we look at the world, they are all talking about still weight reduction and global systems capability with this class of systems. So when we look at total technology change was put into, and that is how Agni 4 took shape. So I was definitely designated as the C4 project director from the nose tip of the missile to the bottom of the missile were totally redone and restructured. And we have first time in the country we used composite rocket motor for the first time for missile applications. And we have proven that this Agni 3 had a launch mass of around 48 tons, and Agni 4 has a launch mass of 22 tons, less than half the weight of the missile, which has taken us lead to the range of 4,000 kilometers. This has happened because of the technology of composite structures and composite rocket motor technology getting proven in the RDO. This is the road mobile system, and it has a range capability from 1,500 or even from lower range it can pick up to 4,000 kilometers. Then came our India's most ambitious project of A5, which is 5,000 and above is called ICBM. So India wants to keep it at 5,000 and doesn't want to call it as ICBM. So that is how 5,000 is our range limitation given to us. And we have a 3-stage solid propulsion canisterized launch road mobile system. Range enhancement is only change in the propellant mass what we are carrying. Coming to the technologies, this is a propulsion system, what I said already, changeover from metallic rocket motor system to a composite, and then switching out from towards high energy propellant. Rocket motor casing, as I said, composite rocket motor casing. Now we are speaking about composite CNC carbon nanotube reinforced motors. Yet to come, it is on design level. Then the technology for the CRMC to the composite rocket motor casing technology, first time in the country developed with the ASL, winding technology, the bonding of propellant and the casing, the NBC technique for composite structure. Then we have other augmented propulsion systems like retro motors. As the name suggests, it is for retarding the force. So we use it for the separation, like these solid stages are integrated together. Once the first stage rocket motor has burned totally, then we need to dispense that system. So even though we use an FLFC cutting system, we cut the motor, but still the rocket motor residual thrust will be very large because they are all large motors. So we need to give another retarding force. So we have auxiliary systems of retro motors of different sizes depending on the class of the system what we are discussing now. So that of the order of 2 times to 3 tons and 3-4 of tons. So it almost amounts to almost 10 tons of retarding force given for systems for separation. Then we have 3 solid rocket motor. I will come to the details. There is a requirement of a velocity trimming package. That is in the uppermost stage, the payload stage, we keep a few velocity augmentation package where we indicate requirement of addition of the velocity to meet the particular range is required. Such VTP packages are also provided. It's again a small biopropellant structure where its fine corrections from the order of 100 meters to 150 to 200 meters capabilities are being established. This Agni, we have totally switched over to the solid propulsion. When I joined as a scientist, I was put to work with Agni series, where it is the first to demonstrate on it. We had second stage as a liquid propulsion system, where in which we want to terminate the propulsion, terminate the burn-off condition. We had the option of either switching off the fuel or the oxidizer, where in which the exact precise velocity for achieving this particular range, the termination was established in the liquid propulsion system. The task was given to me, the most assigned task was to develop a guidance scheme with solid propulsion. With solid propulsion means it is like once we ignite a cigarette, it keeps burning from one end to the other. So all this solid propulsion also is the same that once it is ignited, the whole amount of energy, whole of the propulsion has to burn out and it is available to the system. So where we cannot in between, because we are talking about a system, like for example, Agni 4, 1,500 kilometers to 4,000 kilometers. The velocity requirement at the termination point or the injection points are totally different. So how do we manage the energy from the solid rocket motor? And that was the challenge point. It's being developed as an energy management guidance scheme, and it is totally range independent program. And what I said as a launch point, you need to only reach the target coordinates. That range is 2,000 kilometers, any of the range independent, and angles anywhere within 360 degrees, it will go and reach. So keeping all these features in mind, variable range, guidance is helping, and guidance has to take care of thrust variation and impulse variation, because all solid propulsion has a bound of variation, upper bound, the nominal performance, and the lower bound. So for large motors, the variation can be of the order of, in terms of velocity, it can vary of the order of 200 meters to 400 meters. When I say 200 meters, this class of systems will land up, it has 1 meter per second velocity difference, will land you in 3 kilometers away. So you can know the type of error which you will land up in if you don't have a perfect guidance. This was the requirement with no thrust termination, and energy management scheme has been developed, and it has been proven in all the systems. Agni 2 was my first experience as far as energy management scheme is concerned, and it has done Agni 2, Agni 1, Agni 3, Agni 4, Agni 5, and now we are looking over to all the strategic systems for DRDO, the same scheme of guidance with variations in various small scales. Basic scheme is the same. So what about the energy difference? Like trajectory also, if you see, at the initial phase of the trajectory, the missile goes in the same path. The guidance is there. That is the time it takes either a lofted trajectory or a shallow trajectory, depending on the range. That is why I said nobody will be able to know where you are going and where the missile is heading. And the velocity trimming package in case of shortage, we can only add energy to the system. When it comes to a termination point, and if you are short of velocity for the range, it can be augmented by velocity addition package, where again we do guidance to exactly come to the target. That is by using this velocity trimming package, as I said earlier. And all is possible, guidance is possible only with the advanced navigation system. Even if the mathematical errors are minimized, this is computational speed and system, but we have to have accurate navigation system. Today, DRDO has developed the RLG-based risk navigation system, where the gyros have a class of error of the order of 0.01 degrees per hour and accelerometers within 30 micro G. It's a big achievement, and we are able to get positional accuracy with the GPS element also being there, updating the system. We have been able to get accuracy less than 30 meters. And in our development flight, it is still lesser. We have even seen single-digit errors in our positional accuracy. And mind you, this nuclear weapon doesn't give that precise, but still, that is the perfect guidance and navigation and the control working for the system. Then we have developed a MEMS-based INS GPS link system, which is one order less in accuracy, but they are used as for a redundant system. So here, if navigation system as a main system, And the second system we are going for, which is weighing less than half a kg, that means with navigation system with its own processor and all input processing for the navigation output. But with GPS being there for this thing also, it comes to the accuracy within that 30 meter, as I said. Then we have the missile control system. Basically two different categories. One is the aerodynamic control, where we have moving control surfaces, which are effective only during the aerodynamics. It is effective only during the atmospheric phase, that is up to an altitude of 40 to 50 kilometers, beyond which this is not preferred in the long-range missile. So we are trying to, Agni 1 and 2 had the aerodynamic control, but from Agni 3 onwards, we see it's like a cylinder only, no protruding surfaces. So we are switched over to the thrust vector control totally, even for the last stages, with thrust vector control, that is control is got by deviating the main thrust and getting the control over the pitch and the off two axes. Roll conduction is again by small thrusters, that is the reaction control thrusters, which has a low torque and highly effective in atmospheric and beyond also, the reaction control system. And then for the actuation, we have again mainly two categories: the hydraulic actuation system. There is huge tonnage of forces, control forces required. Power requirement is there, 5 times and more. We have gone for hydraulic actuation system. For Agni 3 and all, we had almost gone to 15 tons. Now, with optimization, they have come down close to 10 tons. But today's trend is to go for electromechanical actuation system. Keep it in view of the hydraulic system, the piping, and related things. We are pushing on the electromechanical actuation system. Up to 2 times we have flown in the system, we have proven, and we to 3, 4, and 5 have that electromechanical actuation system. Today, our aim is to reach to 5 times the electromechanical actuation system. That will be proven in the coming versions of versions 4 and 5. Coming to missile structure, again the lightweight design software to metallic and composite. Associate structures, thermostructural design, full-scale CRT. That is CRT is ground resonance test. For these designs, way back in our first second flight of Agni demonstrator, we had a structural and control interaction. With while the missile was flying, we could see some oscillation. Since the natural frequency is coincided, we can even give a structural damage to the system. So in every design of the missile, complete missile is tested as a ground reference test to know the different frequencies and all the sensor frequencies. There should not be any interaction of structure and the control. So that is taken care by doing the full-scale ground resonance test to know the bending modes and the flexibility flex modes. We model it as first bending mode, second bending mode, third bending mode. Up to third, we are taking care in depth and flex mode. So that is, and a full-scale load tester, 48 tons. Missile is subjected to full load structural test. Section-wise we do, and integrated also the loads are applied to see whether the structure will stand. Again, structural design through SPM and SPM analysis is taken care. Coming to missile aerodynamics. Here we have learned a lesson when we had the first Agni 3 launch. The system functioned very well up to 70 seconds of the flight. We are all in this launch console looking at the performance, absolutely tracking the same predicted trajectory. At 70 seconds, we don't know, suddenly the we have not even gone to the guided stage, the second stage, around 100 or 110 seconds for the guided stage. So it is absolutely following a predefined trajectory, and where it can go wrong, we are not knowing. Up to then it was really Agni 1 and 2. So the only difference Agni 1 and 2 are modern motor. Here, first time we were doing the 2-meter dia. The phenomena of flow expansion, plume expansion beyond the upper atmosphere expanded, so much expanded, and it had a reverse flow and entered through a small gap. 50 mm gap is given for, as I said, the flex nozzle control is used. 50 mm gap is given for flexing the nozzle. So a freedom of, say, up to 40 mm is required for the control. A 10 mm margin is what we are putting. But because of the plume expansion or the knowledge gap that during the upper atmosphere, the flow expansion and reverse flow happening. Those days were the days where we didn't have the facility of CMC within our DRU. Nowhere in the country you can say for this type of simulation. And as I said, it's a knowledge gap at that time point. Then when we see in the post-flight analysis data-wise, we could only feel that somewhere some disturbance to the control system cable. So that is how it was analyzed and found that the flow interaction, jet interaction, and the wave flow analysis. Then we modeled it, and then we have seen that the phenomena is there. Then we have provided a thermal protection system, which is also flexing along with the nozzle. So we got it attached to the thermal protection system, attached to the nozzle, to the missile base, and that is how, if you look at the technology, it is only to do with big thermal protection system, but the whole effort went somewhere in the way to Bay of Bengal without doing much of it. But it was, I don't call it as a failure, because seeing the first attempt of perfection doing the other systems and the knowledge gap, that failure only we learned the lesson. None of this, thereafter, all the missiles which is going through such phenomena has been taken care. So again, sometimes these are again failures, stepping stones towards success. So that is how, and we didn't have, as a country, we didn't have the facilities, and because of total denial of technology, we talk about CNC, nobody gives us. Today, situation is different. We have our own supercomputers doing this computational fluid dynamics and aerodynamics. Full characterization can be done for subsonic, supersonic, any amount of thermal environment prediction, simulation of ablation effects during re-entry. When I say ablation effect, the re-entry technology, when we were thinking of Agni technology as it is, it was to do with the payload, that is the black portion of the system, that coming back, re-entering back to the atmosphere. It is moving with the as high as 5,000 meters per second, 5 kilometers per second and more. And when it re-enters back, it encounters a temperature as high as more than 4,000 degrees centigrade. We can all imagine that the thickness of the payload shell, the RDS structure is only of the order of 20 to 22 or 25 mm thick. And the outside temperature is of the order of 4,000 degrees centigrade. And all the onboard computers, avionics, and the payload, all are sitting within the 22 mm thick structure only. So this technology development by our support was that only led us to think about this Agni class of system. It goes as high as 1,000 kilometers higher in altitude and then comes back. So to that technology development, again it is based on the ablation property, that outer layer of the RDS structure peels off or gets charged, and it doesn't allow the temperature to penetrate inside. So that is how we were able to achieve this technology. It's again indigenously developed by DRDO. And today's challenges are towards hypersonic aerodynamics, drag reduction techniques. We are all working towards the aerospace on top of the nose tip so that drag can be reduced. It is well established in space vehicles, but as missile configuration, maybe future systems will be coming up with that. And again, 3D moving grid flow analysis, a dynamic analysis of the system, and thermal testing models for AN3, taking into the communication blackout and ionization effect, all its progress. And when we talk about missile launch, if you see the history, 1960 onwards, all other countries are launching missiles of this class, and 100 and 200 numbers they are launching, they establish the accuracy. If for us it was, the strength was simulation is on ground, that is hardware simulation and CFD simulation, all tested together. The hardware simulation which has brought out the number of tests declared, something like three consecutive flight tests successfully proven the system is declared perfect, and it moves towards production and things. Because we have a large amount of parameter monitoring on board and evaluating the post-flight analysis. So that is the type of success rate we are getting. In a nutshell, coming to the total AGNI technology, starting with the CN3 vehicle structure, as I said, temperature 4000 degrees centigrade set to 50 degrees centigrade, which is facing an aero load of more than 30 G and more, and propulsion with a flat nozzle control system with very high impulse and mass fraction, like composite casing to the total propellant stages, an aerodynamic characterization, hypersonic flow, CFD analysis. Then we have mobile launch control, the integrated transporter and control center for launching, safety, security and reliability. The launch control center even incorporates the command from, for our country, it is the Prime Minister of the country, is the commander-in-chief who has to press the button on a use of this system, this class of system. So that also has been built. For our given development launch, the command control system is integrated, and then we have advanced avionics, as I said, inertial navigation system, totally distributed architecture, a total digital system, the controllers, onboard computers, all the systems, all the packages are intelligent packages, and every instant of time monitoring the status of intelligent systems, embedded computers. In the launch console, before missile is launched, we monitor more than 600 to 700 parameters. First, when I went for the interview for our promotion, first time I was working with missile on the navigation and guidance side. I have not much got into the integration side. I was asked what could be the total length of the cable what you have used in the missile. I was thinking missile is 20 meters long, so I will multiply by some 100 times and say some 2000 of that order. It is running into kilometers and kilometers. It is not 2000 meters. That time the knowledge level was, I was thinking maybe 2000 meters, something like that. But it is 2000 kilometers. If you take the connectivity from strand to strand, that more than 40-50 intelligent units and n number of connectivity is happening. So each one of those connectors, one of the strand of that cable comes comes out, the missile is gone. So we have to be, it's a very critical system, we have to test it, like we go in steps, functional test, end-to-end connectivity, 1:1 cable end-to-end is checked at different levels. So that is the type of preparation for a missile. It goes, final integration itself goes on floor. That is the type of effort the scientist has to put with utmost dedication. And then we go for the mission for the launch. This is, as friends have mentioned, 19 April 2012. Actually, we were supposed to launch on 18th. Because of the weather, we had to, there was heavy thunderstorms and all. We didn't want to miss the data, any of the telemetry data. Visual video systems are there. So we had to postpone, we had to reply to many from the headquarters why we are postponing. So it sometimes happens, a lot of visibility for our system development. And this was the, I think, 5 maiden flights from our Miller Island, where the mission had excellent success. The first attempt itself we had got, I think, a pinpoint accuracy. And we had 3 ships monitoring at different Bay of Bengal and beyond in international waters. We keep our ships in a triangulation and get the data to our telemetry system. And I don't know what a feeling, what a great feeling that day was. I think all Indians are proud of that moment, I'm sure. That was the type of First time when we were sitting in the console for launch, Agni demonstrator flight. We had project directors sitting. I was one of the mission. Then onwards, I was part of the mission. So I was in a console there looking at the parameters, missile height, velocity. That was my duty to see for it. First time the project director felt the missile is falling down. I'm talking about Agni demonstrator time. They all said, gone, the missile is gone. I was the only one who was yelling out saying that no, it is climbing height is building, velocity is building, it is going up. Because it is a camera view from very high when it is going. The camera view was such that, so that again it's an experience. Nowadays we see that like this also we don't see any problem. But sitting in that console as a project director today, when the launch countdown starts, we have irreversible activities. When each auto launch happens, it is T minus 2 seconds. The heartbeat is so high, we don't know what we are. It is like a dramatic form of events happening. And at that moment also, PD has to be, project director has to be so alert to take decisions. Whether to go ahead with the mission in case of any hold, or whether we can release the hold and go ahead for the mission, or whether we have to abort the mission. So in those instants of time also we have to be so alert. So that is an experience which one can see in that place of atmosphere. Thank you. Thank you.
Good afternoon. Indeed, we have privileged lecture. My question is very simple actually. Women are generally associated with something being very caring and very tender. How were you driven to something as destructive as missile?
Still, women are still caring and tender, but women makes the difference. I think we are proven it, you know. There is nothing like women and all. When I joined it is like, I feel I am a scientist working for a particular cause or working for the assigned job. So that was the only feeling of me even today. And science doesn't know, as I always say, it doesn't have any gender. It doesn't know who is doing the job, who is doing the experiment. So it has nothing to do with women being there.
It's very rare to see somebody who reach that level of height and to be associated with something I mean, I personally would, it's the first time experience for me to see a lady who reach such great height in field of defense and developing such facilities which can protect the nation as a whole. That is why I was curious what that drove you towards.
Thank you. The secret is that I have developed the guidance key for the Agni system, which is the brain for the missile. So nobody can declare the brain is there. That is how. It has nothing to do with that. All the people who are working for our system, men or women who are proven the capability with commitment and some of them their life. It is to do with IT. I have been assigned one job, so I came with the background, entered my college was in missile guidance. So I started I was given the task of working on national navigation systems and guidance for the system. It is established in steps, and you do your job, rest is some facilities. It's true for every scientist. There are so many other colleagues of mine who are some of the technical technology directors and project directors, all are in the pipeline. It's one has to be dedicated. There is beyond doubt commitment and the type of involvement in this system. And like you all read, being as a student, as a scientist, I am a student even today. So we need to read and know what is happening around to compete with the world. We need to think on the technology, then only the outcome of the system comes as global system capable of all the technologies. So that way, I am no more a scientist as a student.
Hello. I have two questions basically. First, about the range of Agni 5 demonstrated as 5,000 kilometers, but Latin was stated standard stated that the range of Agni 5 is more than 5,000 kilometers. Is it really true? And my second question was, what are the different ways to get into different research?
Who mentioned it is under rating?
Understated. It is more than 5,000 kilometers.
Yeah, I remember one of the Chinese newspapers mentioned about it. Because they know with this weight and this type of system, yes, it has more capability. I said no. ICBM is our Indian government didn't want for anything called ICBM. We need to add a little more of the prevalent quantity what we are putting in the stages, or enhance by one more stage you are crossing the scope. Okay, so it has nothing, range has nothing to do with technology is well within us. But as an Indian government, we wanted only 5,000. So that is all, we are proving only 5,000. That system may have more capability. So what you have read is true. And coming to absorption and the sciences in DRDO, we have global within the country entrance test. But unfortunately, for the last 4 years, it didn't happen because vacancies have to be given by the government. Vacancies. I think with the new government, we may likely to get some more vacancies, maybe 500 like that. Or so that there will be an entrance test through which you have to appear for the entrance test, and branches varying from electrical, electronics, mechanical, aeronautical, all branches, chemical, all branches, computer, and all branches engineers are able to get into that through this test and interview.
I heard that Amplify has multiple orbits. Is it true?
Now, Agni 5, we have thrown away a single warhead, a variant of it that we have already technology development we have done for the MARV, that is multiple independently targeted vehicles. It has multiple RVs, re-entry vehicles. Instead of one payload coming, there can be 4 of them, 8 of them, or whatever way which that payload can house. So that class of system, the technology guidance has been established by my group team, and we have, as and when government says we go for the MARV class of system, we will take up that. Technology is we have already established. So we will be able to, from one missile, different targets, and where across some footprint possible to.
First of all, we are happy on.
Thank you. Wishing you all a happy autumn. Then I come from Kerala, so the Hyderabad Kerala community was looking for me today for the Onam festival. I said no, I am committed to IIT Guwahati. We do a lot of perturbation studies. It's not that one trajectory nominal is taken. We perturb the aero characteristics, we perturb the velocity parameters, we put into wind conditions, all type of disturbance into the system, variations of like thrust misalignment, all are put, and then only, like we do the Monte Carlo simulation of the system. So, under performance of each stages, each system, except the avionics, there is nothing called underperformance. It performs or it doesn't perform. Rest of all the rocket stages and thrusters, all of them put to in different weather conditions we take, and then do the analysis. Under all these conditions, all variations we are able to. I am talking about a system which has a capability from 3,000 kilometers to 5,000, one single missile. So it can incorporate any variation in the energy between that type of range difference.
So it can control itself in a
Yes. So in Agni 5 we have 3 stages of rocket motor, wherein their second stage onboard closed loop guidance is there. So from second stage energy onboard, second stage and third stage, and we have the velocity swimming package in the payload. 3 stages of guidance in a closed loop is there to take you to, or to take care of all these uncertainties.
Another question is that you just said that the construction of the second file, all those things are in the primary feature, but it is considered the Supreme Camera as a president. Why he is not involved in that?
It is not, it is a government policy. Government for the chain of operation for the command structure. It's by the Prime Minister of the country. Today it is like that. As the Constitution stands, Prime Minister has a suitcase for all these strategic systems. He is the command of the strategic system. That is the government regulatory constitution.
Good afternoon, ma'am. Why is that range limit of 5,000 imposed on the site?
Again,
Why is that range limit of 5,000 imposed on the site?
no, India per se, when So that is why if you start talking about beyond 5,000, someone else is the target. So that Indians want to, generally missiles are attempted in that nature. If a global requirement is there, we need to augment by a state.
If we can handle that.
Yes.
Good afternoon, ma'am. You were talking about the ballistic missile defense system, which we possess. What is the counter to a ballistic missile defense system?
What is the?
Counter to a ballistic missile defense system posed by other countries.
That's what I said. Today, for this Agni class system, no country has developed anti-ballistic missile defense. But it's traveling at a speed of 6,000 to 7,000 meters per second. And when it is in cruise stage, as I said, if you take the time of flight of the order of 1,000 seconds or more, 10 to 15 minutes, somebody locates you at the cruise phase, and as I said, it's not known whether I'm going for a launch of 3,000 or 4,000 or 3,000 to any kilometer I can go up to that system, and guidance is initiated in 3 stages. So if anybody is tracking you at different levels, the turn angles what indicates by the position and velocity, nobody can determine the range what I am trying to do. So that is the beauty of this energy management guidance system which is developed by me. I want to tell that I'm so glad that this system has been adopted not only by me, the other systems of this class within the country.
Of India, we import almost $6,000 to $8,000 million weapons and other things. Well, why is it lack of technology? Is it lack of manpower? Or what is the reason we are importing at such a huge quantity? And how can we recover?
Agni missile is concerned, it is totally indigenous. We are 99% of indigenous content today. Maybe few ICs and all may be coming, but that is commercially available.
I'm talking about other defense equipment we import. India is the biggest importer of defense market in the world.
True, that is, India thought about defense only way back in 1960s and 70s. World across has established the defense technology. As I said, this class of systems were left and right, hundreds and 200 numbers of tests were carried out in 1960s and 70s. Whereas India as a country, still developing country, we got guided missile program only by 1980, and then today we are global reach and global capability because technology-wise we are superior, and development of those things happened in a fast track, and we today's our systems are far competent with the world across systems. Export of certain of the technologies and movements is a part of our development because our countries and industries have not come to that stage. But Agni systems today our industries are developing our products. Whatever we are developing in 200 systems, all Agni 1, 2, 3 are coming from industries. Rocket motor casing, rocket motor. Even the casting is by industry. So there is knowledge are produced, sections are produced, totally indigenous. Nobody gives anything in the name of something. So that was blessing in disguise. Indians could develop and we could indigenize our systems. Equipment, measurement, some of them, whatever is commercially available, it is coming here. Our country's industry is progressing, the governments are supporting, so it will come up. One day you will find, when your turn comes, probably things may totally make a turn, we may be exporting it outside. Systems. We are talking today of missile systems getting exported. So they will come. You are all the key runners for that. My best wishes for the same. Ratman for
I think we are all in the opinion of the perfection and precision involved in this kind of technology. Thank you, ma'am, for enlightening.